We've installed 2 tree motion sensors. They're put out by Picus. They have batteries installed in them, but they go into a sleep mode pretty quickly. So what I wanted to do is just show you how we activate them, and then the sort of data that it'll do a live feed to my phone. From here, we'll then go to the sugar gum further down, where Damien's got an arbortom set up. So in pretty much exactly the way that Lockie did the Fagus up in the bot gardens, we'll do the same thing to the sugar gum, and then we'll take both sets of data back up into the room and see what it says. So yeah, the tree motion sensors, how many days do we get out of the battery?
Well, it says 20 days, but it's never been that reliable. So let's say somewhere between 10 and 15 or 10 and 20. They're actually pretty fickle. So I'd be really nervous about putting them on 20 days and expecting it to. And so to that point, we set up sensors on the tree over there as well as a control tree, and all of that data is corrupted. These ones, when I took them off yesterday, one of them said it still had a day's worth of battery when it should have had well and truly longer than that. I guess before Ben starts that, I'll probably tell you how we're using them.
The most common use.
What we're actually using them for. We don't use them that often, probably only a couple of jobs a year. And it's just testing for tree stability when a tree owner has a concern about it. Haven't come across a tree that has recorded it as unstable yet, and I've even tried it on a few trees that I suspected of being unstable, but they still had a low level reading.
Most common application for it is root damage in or near the structural root zone, and people are concerned. So put the sensors on, wait for the wind to blow, download the data, and then Ken James's work. Where are you, Ken? Hand up. He's run away again. Every time I ask for Ken, he's going to run away. Ken's done a bit of a traffic light system as to, should be pretty good, getting concerning, and could be concerning. So I'll turn these on.
And from that point of view, they're a little bit of a challenge to use, actually, because you've got to wait for wind. So manufacturer says you should have wind greater than 45 kilometres per hour for at least 2 hours. And the testing period would be 2 hours. So we've had 2 jobs sitting in the calendar waiting for wind now for, it's probably 2 months. And look, the wind will come when it comes. And then the wind seems to always come on the weekend. I don't know why, or in the middle of the night. So we end up, rushing out there last minute on a Friday arvo, fitting sensors, getting them back on Monday, hoping that there was no data corruption. They're not the most easy devices to work with from that point of view, just from a logistics point of view.
So each sensor's numbered. Thanks. Each sensor is numbered, and we can just tell it to show us some live data. So 27. He needs to talk in the bottom one. And it's just showing us live data as we go. So there are a fair few people here earlier that did see this. For those that didn't, what it's measuring, I guess, the change in inclination. We're seeing it in only one plane, but actually if you could imagine a top-down view, it's measuring it in 360 degrees, no matter which way it's moving. So that's for both sensors. So we had them on for about 2 weeks prior to pruning the tree, and I think we got another just under 2 weeks after pruning the tree. First time we've ever done that from a before pruning and an after pruning event. So we're not really sure what we're looking at when we go back up into the room. So feel free to ask plenty of questions. We're up there.
Dan?
Yeah.
Installation height. Is it?
So Ken's probably the best person to answer that, but the specification is 1 near ground level and 1 at around about 2 metres. And that goes into the software, greater than 2 metres. Basically, and the other thing that we normally do when we install them is you'll install it on the subject tree and then on another tree nearby, and quite often we'll also put in a wind speed and direction meter to record wind speed as well. For this site, the Geelong racetrack, there's a Bureau of Meteorology site just there, which is less than 1 kilometre away. So we've downloaded all of that data to correlate the wind data with the tree motion sensor data.
There's a gust there, then you get a spike just now.
Yeah. I wasn't watching, but I just saw it spike a little bit there. Yeah.
The tree nearby, Paul's a bit difficult because it needs to be a tree that's similar sort of size, and particularly if it's a private backyard, you may really struggle. there's this bit of a vandalism issue. One of the sensors that was over there, it got ripped off the tree by someone.
Or by a dog, or who knows.
Or a dog, yeah. So,
Cool.
you know, I've gotten lucky, particularly on construction sites where there was already temp fencing around a street tree. So I was like, okay, I'll put it on that tree for a couple of days and feel like it won't get knocked or stolen.
Yeah. I don't know how many data points it's recording per second, but there's lots. It's 20. Sorry, 20 per second. So when we downloaded the data yesterday, it took 2 hours to download, and then we had to sort of cipher through or filter through that data. So we've got a bit of a selection for this afternoon, but there's a lot more that we could look at. So we'll tell you what we selected and why, and then just see what it looks like. So there. Any other questions on the tree motion sensors? There'll probably be lots more once we see the data.
Have you made the current wind speed to kind of make use of that data as well?
What you tend to do with the current wind speed data is it tends to give you spots to go and look at within the tree motion sensor data. So generally not a lot of point in looking at it when it's calm. So you look at the wind data and go, okay, we had a good wind spike through there. Let's have a look at what it was doing for that 3-hour period. What does this all mean? And one of the big things I think that we keep forgetting is that whether it's the tree motion sensor, whether it's a climbing inspection, whether it's the Arbitom or the Picus or the sonic tomography, that is actually not telling us what to do. All it's doing is providing us with additional information. And I guess one of the big things for me is no matter what it is, what does that mean? How do I translate that into recommendations? How do I translate that into real life? How do I translate that to this tree in this particular point in the landscape? And again, going back to that earlier statement that Ant made, you know, I'm just a tree climber. Well, don't underestimate the value of that. And I guess right now, don't underestimate the value of something not scientific at all, but just a mallet or a hammer to sound your trees. You know, that can tell you a hell of a lot. And you may need the backup of the sonic tomography, but you may not either. So, yeah.
Lockie touched on it before that, you know, you should use sounding prior to doing sonic tomography. It's going to inform where you put your sensors. And it's probably like it'll be one of the first things you do before you test a tree. I just wanted to stop at this one because we did a walk yesterday, we tried to find a good tree that we could that easily test and demonstrate, but also one that was obvious in its sounding. And this one, although it wouldn't, was fairly obvious. So, you know, the other thing is, it's not going to be obvious on this one, but when we get over to the sugar gum, it will be. The other thing I've seen is people really smacking the crap out of trees when they're sounding. And it's unnecessary. You're not trying to kill it. Just lots of small taps, and you will hear changes as you just sort of really find your way around it. Sometimes you'll have to remove a bit of bark, but like, you know, and pay attention to the features that you're seeing, flat spots where there's no swelling, you know, and just work your way around it. Yeah, if anyone wants to have a tap, they're welcome to. I guess same but different to Lockie's machine. I've already put the nails on, so it should be pretty quick to put it all together.
Is there an ideal height to be setting all of these?
No, so that's a great point. There is no ideal height.
Somehow I've screwed the monitor up, Damon. It's been working all the way back and now decided to do it.
I think we're took one on the big jobs. Yeah, that on the big jobs. That'll be boss. I'll try that.
Plan for weeks.
And one thing is, we have to stand for July 1. Can you come on? That's the other thing. You get that on what the first? Oh, but yeah, I'll you know, let's get Peter. They get the sun. They have this amount of your own.
That's the lot, Damien?
Yeah, that should be the lot.
Are these supposed to be connected?
Thanks, bro.
That they
Our question is,
Sorry.
just asked, is there an ideal height? And no, there isn't. It's wherever you want it, wherever you're wanting to test, wherever there's. But sometimes
Sometimes you want to test where there's something that's a limit with the limitation, like testing how much you
at the K patch here, and you want to test there, but there's of course a limb in the way. So you just kind of got to make the best of a bad situation in those examples. So the difference between this machine and Lockie's, well, one of the differences, should I say, is there's no caliper. So I've already done this because we've already tested the tree. A tape measure around the tree, full circumference, then measure all the sensors away around the tree, and then measuring in off a perfect circle to give the shape of the trunk. And if you look on the screen over there in the back of the ute, you'll see there is a representative cross section. Power it up, they should all be green except the last one. Which they are.
and then I did. Yeah, I did it. That made a noise.
Yeah, it made a noise. That's just telling the computer which sensor's which, so they know where they are now. And one hit on each sensor. And that's sort of like the setup phase.
How?
I got to re-hit number 3 and number 4.
Good. That's it. It's then no, he lives on there.
Amazingly, it works perfectly when you try it before you put it in.
And then it decides to have a connection.
We're good. So then the actual test is lots of hits on each sensor. Does anyone want to have a hit? I've done it before, so I'm happy to give us the hammer.
One of the most annoying things I think from doing these sort of level 3 assessment is doing it on trees that you clearly don't need to. And either clearly don't need to because the tree's rock solid, or clearly don't need to because you can drive a bus through it. So anyone that walked past the peppercorn behind us, absolutely no point in doing it today. Like, you know, you could fit 4 kids in there with a cubby house. And I guess the presentation of this data is probably one advantage, but doing it just for the sake of doing it, I think, is just a waste of people's time, effort and money. And again, it's a level 3 assessment. It should be providing us with additional information because we're uncertain of something. And so for me, I guess, most times that I'm uncertain, I'd be looking for a scan above the area that I'm uncertain, one near the area that I'm concerned about, and one below, trying to get a pretty good picture as to where is it, how far is it extending, all of those sorts of things. And we're nearly at number 14, I hope, Damo. But
Getting that. Well, you might have seen it. I'm going to go with this counterpart.
yeah, wait till you finish.
Might have seen some of the sensors moving. I would normally stop all of the sets and adjust that. if that happened.
Yeah, so I'm after 40. I'm part of it. So it wants to be sub 10.
Right. So you can crowd around and have a look at the screen, but we will show it back up the top as well.
So speed between each sensor. And I guess to Lockie's point earlier this morning about replicability of this testing, I was a bit lazy when I did that with the tightness of the sensors. Some of them were moving a little bit. We tested this tree, got here at like 7 a.m, started setting this up in the dark, and did 2 tests this morning, and they were 4% strength loss and 5% strength loss. So, this is a significant difference here at being at 16, and it's probably because that was just a bit rushed. I should have turned that off.
Yeah.
Have you done the scaling on it?
Yep.
So you probably already said, why did you pick this tree?
Because it was really close to where we're at. That's the main reason. And that there is that patch of decay through there, and I was curious to see how far it went down. But zero concerns with it whatsoever. But primarily because we're close to quad rooms. Yeah.
It was convenient. We could park the car here. Nothing really more than that. So as Ben said out in the field, we fitted the sensors a couple of weeks ago with the idea that we could then prune the tree and see if there was a change in the data. I don't know if that's what's happened. Probably first thing I'd say is maybe there's just simply not enough data actually. So what you're looking at here is we've got wind data on the left and some of the TMS data on the right. Now it's really hard to pull the TMS data out of the software for a long period. So Ben and I kind of scrambled at it last night, and we basically pulled out the top 30, the highest inclination over a couple of days, just to show a bit of a snapshot of sort of what it looks like. It's doing 20 readings a second, so there's a lot of data. But you can see here on the wind, for example, Ant pruned the tree, I think, on the 15th. So the only thing really we decided to present was some, moderate wind data prior, so the 14th, and then moderate wind data after, so the 20th and a few other days, and kind of excluded this period where there was actually a wind event with stronger winds because it couldn't be compared to anything. But I'll still show you it. Over here we've got data from the 12th in orange with I'll look on my screen, with sort of 0.28 as the highest. And then, Ben and I were like, oh, wow, look at that. And then following the prune on the 20th, it's clearly lower until you start adding other days in, and then it kind of all gets a bit jumbled up. So as I said, not enough data to really draw anything conclusive, nor did we spend enough time on it. This was last night that we pulled the data off to call it any form of scientific study. I'll add a few more days in. So there's a few. I can go to the 15th. When do you reckon you were the most disruptive during the day on the 15th? Well, hang on, we'll get to that. See if there's any heavy spikes. So adding in a few more days there, you can see it's all pretty jumbled. I did try and group it a little bit. The oranges and reds and yellows are pre-prune, and the greens are all post-prune. And this is only a 2-hour period when the wind was pretty similar. We're talking probably mid to low 20 kilometres per hour was that time frame. But the actual TMS software is here. This is what the data looks like, and I guess the TMS software wants to, for a test, it wants a 2-hour period. Ken and I have zoomed in on that a bit, so I'll zoom back out. And what we're seeing there is we're actually seeing the control tree and the control sensor and the base sensor laid over the top of one another. And then if we go to top view, we're seeing like a scatter plot of where the trees, how the tree's moving in the ground on the day. And on some trees, particularly when there's a really strong wind event from one prevailing direction, like if you were talking about a nature strip tree where you were concerned about its anchorage because it had a footpath on one side and a road on the other, that scatter plot could tell you something really, really valuable. So this data here on the 17th of May was, if we go back to the wind, was the heaviest wind. That's one of these peaks. And we're in the kind of low 30s, 0.32, 0.33. And when do you reckon you were most disruptive? See if there's any...
On the 15th.
On the 15th.
Yeah,
Smacking big stuff out?
yeah, it's probably about 2 o'clock,
2 o'clock.
maybe.
So I'll go for 1:30. That's AM. You got no idea how much I fight with this program. Actually, you see it didn't change. Yeah. I think it's one of the least user-friendly programs I've ever experienced. And the sensors are a complete dog of a thing. They're Bluetooth. They're the slowest Bluetooth you'd ever experience.
How many other brands are out there? Are there many others? Or?
There's the one Lockie's got with the rude name. And is that it, Ken? This one and the one Lockie's got? Other brands of sensors?
There's the one Lockie uses with that unfortunate name. What's the FAKOPP? If you want to type it in, people have been typing it in their phones. Quite a good website, FAKOPP, which is a Hungarian supplier. This is a German manufacturer who specialises in agricultural spray equipment and computerised that. And this is a bit of a sideline for them. So there's not much development work going on with this one. And there is another one in Hong Kong. Since China's taken over Hong Kong, I have a research paper if anyone's interested. I've been sitting on a committee. They've got a research project sticking them around Hong Kong. And that's an in-house development, but they've got access to all these Chinese developers. They're very clever. They're actually way ahead of us. Yeah. So, but here, two commercial ones, Hungarian or German.
Yeah. So this is that time period from 1:30 through to 3:30. I don't know. Look, it may be marginally higher. There is some peaks there. Yeah.
It's possible to interrogate the data, and it's used to measure the wave heights of waves at sea, which is important on the impact on oil rigs, which is what my supervisor does. And you can look at not just the number and how high it gets, but you can look at the variability in the data. Is one moving more than the other, even though they get to the same tilt value? And that is done with looking at the mean and the variation or the variance of the data. And if you have it on two trees side by side, you'll never get any other data than this. It's like in nature, like waves. You never get two data sets the same. But you can see if the average is the same, and then the variation, which is the variance, square root of variance is standard deviation, which everyone knows about. So you're just interrogating the data. You can definitely tell if one tree is moving more than the other, even within the same range of tilt. So there's a lot of information in that data that the manufacturers are not even using yet. I've published a paper on that and explained this analysis of the data, but no one reads my work.
We do, Ken.
Well, so I can point you to that, and you can get a lot of information. So you can say, did the tree move more in this wind event than the last wind event? If you prune a limb off, will it move more afterwards? Well, there's a lot in the data. We're only just starting this.
And it would have been great to be able to compare this to our control tree, but the data's corrupted. So we don't have anything to the control tree was going to be left unpruned. So it may have shown us different results. Benny, have you got anything to add? That's all I've got.
No, it was like for us. It was interesting initially in that under similar wind events, one appeared to have greater inclination than another. But then once we interrogated more and more of the data, I guess it just got noisier and noisier. We initially just looked at two events, one prior, one after, and that's about it. But I guess for me the big thing is, hey, it's something that we haven't done before, because the most common application of the tree motion sensors is generally for root damage. And this was interesting as in, is there a difference between prior to pruning and after pruning? And I think if we interrogate the data a bit more, we probably will be able to see something there, but I don't know. But with more of it, we should be able to demonstrate that in the future. And we may be able to go down as far as Ken's stuff, as in how much mass damping is happening on this tree. And if we take a branch of this size versus this size, how much of an impact is that going to have on the whole tree? We don't know yet, but I guess this might be part of the way, or starting to head in that direction. So yeah, I'm keen to continue on. Ken's got a question.
Can I ask you some questions? So we haven't rehearsed this, so I don't want to put you in a difficult
Shall I hide
position.
under the table?
But let's see how we evaluate that data on that tree. Firstly, what's the maximum tilt you've recorded
Over this right here,
on your data set?
what's 0.29?
0.29. That's 29 hundredths of 1 degree.
Which means it doesn't move.
Where would you consider the tree moves from a stable to an unstable condition?
Well, the only thing I'm going on is your research, which is 0.6.
And what does my research say?
0.6.
Okay,
have a further look, and then beyond, and then was it 0.8?
Well, I'm saying 0.6 because that's where I think the soil failure, that's the first failure. So my second question would be, do you consider that tree is within its limits of stability?
Yes.
Absolutely.
Yeah.
Why can you say that? Absolutely. Because of the data. It's not an opinion anymore. You have data to back that up. Does it need removing? How do you
For
know?
a different reason, but not for this reason.
Not from the data. You've got some data to support your opinions. Is there anything you see in that data that is contradictory to what you think of the tree?
No, it's what we were expecting. We weren't expecting to see
Okay,
an
so-
unstable tree.
I think it's a trivial sort of non-thing about this data, but it's a very stable tree in a not windy area, and it's doing exactly what you think it does, and you've got the data to prove it. If that tree had been cut in its root plate, you might see something different. Now that might happen next week or next month or next year. And that's where the baseline data is very valuable reference data for the future. It may not give you an answer today, and you might, I wouldn't want everyone to leave this room thinking, oh yeah, what use is it? It's actually confirming very absolutely, that was Ben's word, that that's a very stable tree. We know that, but you've got data to prove it.
And the other thing about root damage that I've thought in the past is I've been asked to do the tree motion sensors on some trees where there's been a heavy site cut and town planning's pulled up the developer on that and said, right, you need to demonstrate that this tree's still okay. And maybe that it wasn't too far away from, it was 3 metres away from the tree. So we're not talking about half a metre. We're not talking about, when I arrived on site, I didn't think to myself, well, this tree is definitely unstable. It's had one whole side of its roots removed. But so we tested it and it was stable, according to the data. But That might not be the case in a couple of years. Decay might get into that root system, and that's probably a whole nother can of worms, and it's not something I've actually dealt with yet using this system. And from town planning's point of view, they probably put that issue to bed. So I don't know what happens with that tree in the future, is my point. Yeah. Any other questions?
I've got one. It's perhaps partly a comment too. Like what I was really, I guess, hoping wouldn't be the case is that all this data became obvious that post the prune we were getting greater movement at ground level, which would basically align 100% with what Ken's suggesting, that because we did remove a fair amount of mass from the tree, so therefore it might have accentuated that movement at ground level, but it looks like we just don't have enough data.
Well, it looks like it was going the other way, Hank.
Yeah.
There was less. It looked like there was less movement than more. But again, we're not experts at interpreting the data either. But
maybe that would be the case if it was a single stem tree, a tall single stem tree, a different shape, different form.
Yeah, very neat shape.
Yeah.
Have you given a consideration how much sodium you took out of it to alter the whole overall movement?
Well, I think the technical term was it got spanked, and and a hell of a lot was taken out of it.
Can you butchered, by the way?
Butcher's precise trace people don't.
Yeah, but it's not. I mean, it's not surprising that there was, I guess, less inclination in the tree after the pruning event. That to me is not surprising at all. And it's probably what we were trying to achieve, really. But it'd be great if we could actually get the data to interrogate the data enough to say, actually, this is what happened, and by this much. But that's possibly a fair way down the track.
So the question is, do you have a before photo of the tree?
No, I'm not.
We do have a before photo. I'll hotspot to this.
Hang on, hotspot to mine because it'll auto connect.
You can answer and I'll find it. I'll try and find
That data on the screen is the tilt data for the base of the tree. Is that right?
Yep. No, what we were currently seeing was both, was the control and the base.
Okay, well that's what I want to point out, that there's a tilt sensor about head high, about 2 metres. Now that's a massive tree, and the tilt sensor at 2 metres high is different than the one at the base. It's not the same. It's showing that the trunk is flexing. Even in that massive tree, that is not a rigid object, it's a flexing object. And in my experience I've done a couple of 100 trees in my studies, the biggest, most stable tree where you get no data down the bottom, it's not tilting, even the biggest wind. How can I present that data? There's nothing. But that's why the sensor's up the second one, is it shows that the wind's blown. So you can get, even with no data, the tree didn't move at all, it's really stable. You didn't get a wind. So we had to get the second one there. And you do, and you can actually put the second sensor way up the top and get much more information. It's difficult because of the nature of its accelerometer. It measures tilt and movement. So you can't use that just for tilt, but you certainly get evidence that there's a lot of things happening higher up the trunk. So the two link in together. Yes, there's a big wind blowing. No, the tree doesn't tilt. And big stable trees with a massive root base, flare and root system, you can't get any data out of them, but you absolutely know they're really stable, and you get zero, which is actually what you want, but you can present it, and the data up top tells you that you've had big winds.
Is there any difference between foliage mass and timber mass? Like if you're cutting off the foliage but leaving long stubs or long branch section,
Have people heard of lion's tail pruning? which is banned in America. That was in my second presentation. It's where you prune off the lower branches and leave with a clump on top. You know, they think it's like
branches out.
Yeah, so the branches out. Now, a very good example of a tree that naturally happens is a lemon-scented gum. So we have trees that naturally line stun, but line stunning is really bad.
That was the before photo, folks.
What they've found anecdotally is that they get much more failures if you take all the mass off the lower portions and leave the mass on the top. You turn into sort of like a palm tree type look. So that style of pruning is bad. Why is it bad? They can't explain it. My explanation is you've taken the damping of the lower branches off. They actually have a function. So that's an example of a pruning technique banned in America because of the dynamic. Statically, it seems okay. And my wife's Italian. I've been to Italy, and the Romans prune their pinus, same as down at Queenscliff, and there's a trunk going up with a little tuft on top, so it does work. But even in Italy, I've given a presentation, a guy came up and said, "Oh, we're having a lot of trouble with these trees because they're failing all the time." So they do actually fail, but you don't hear that.
Sorry, probably going a little bit off topic, but Ant, you made a comment when we were out on site regarding pruning. And I think one of the big things I'd say from a focus of pruning point of view, it is certainly something that you need to be very skilled at, very experienced at, and something that you come back to. But one of the big things I don't think we do very well at all as an industry is formative pruning. And I know from a pruning point of view, probably the most complicated and difficult decisions I've ever had to make as an arborist hasn't been on a big mature tree. It tends to have been on that semi-mature, and I guess if you're talking human terms, probably that 17, 18-year-old sort of semi-mature adult, as opposed to a juvenile. Like, doing the formative pruning on our younger trees has got to be done by the most experienced and best people we've got, because you're setting your entire population up for the next 50 to 100 years. And then at the other end, where we are managing those old mature trees, we need another level of skill and care as well. But let's not lose focus on the forest of the future either. Sorry.
It was a lot of it was taken out.
Oh yeah, there was a lot taken out of that sugar. Well, like I said, it got spanked. So yeah.
Just how often would you have to do that to find a trend in that data? Like,
Ken's probably the man there. That's a question. But I would have thought just repeatability over time, and like this is the first time I've been able to capture data, just letting the wind do its thing, have a specified pruning event, and then capture data after it. So just being able to organise that in the landscape's hard work. And I guess the more we can do of it, the more we can see whether there's any correlations or not. But Ken,
Sorry, what was the question?
How much data would you need for it to make a difference, or when can you say, hey, this is what's happening?
As in pruning?
No, as in proving what's going on, or challenging what's going on. How much data capture do you need?
I could start and answer that by just going back one step. What can we measure now with equipment? What's possible? I mentioned the wind loads. I can measure that, but I don't know how to use that information. The tilt is a measure of its stability in the ground. We can measure. What else can we measure? If you can think that up, I've got a few ideas.
that's what I'm asking. Like,
Strain? Like, can you go strain in the fibres?
I've been working with some palms in Spain. I'm talking to Port Phillip guys here. We can now, instead of using electronic measurements, we can take measurements of videos. So I'm suggesting that with a palm tree as a start, because it's easy to see, you actually put a light, a little LED up the top and down. I think it's a set of Christmas lights, spaced exactly 1 metre apart. There's take a video of it in a wind, and with a palm tree, you'll get the sway of it. Keep the camera still, calibrate. The sensor will calibrate, will measure that metre and then calibrate the movements. And there's a software I was showing at lunchtime. It tracks, it's called Tracker. If you want to dial that and look at Tracker, free software, open source, so copyright free, it will track that pixel on the screen. And then you get your movement, you get your frequencies, your displacements. So maybe you don't have to measure down the bottom, you can measure up the top. And see that tree, for example, imagine you put lights, because you do this at night, a lot of storms come at night, you could do it in the day as well, but you put lights on the trunks on different branches and just see what happens. I've got a video in the second presentation where they did that 15 years ago in Chicago at a conference, and they used NASA technology, but we've got the same technology now. And they pulled a little tree and you can see all the branches going around. So I think we're on the cusp, and we haven't got to talking AI yet, we're on the cusp of having really good technology and using some artificial intelligence and software analysis to see where we go with this, investigate it. I don't know where we'll end, but I know where we can start. So if anyone wants to stick some lights on trees and we monitor the motion in a wind, you don't do anything, you don't compromise the tree, you're not going to have any liability for failure. But then we talk about pruning, and as an engineer, I've picked up a lot of comments about trees over the years. And I used to share an office with a tree expert, a man called Clive Sorrell, and he had a nice way of joking and talking. But he told me that trees are shedding organisms. This is something from a Kozlowski, I think, an American author. So they do shed. It's part of their growth. And if they balance, if you want to tune up an instrument and balance it with a bit of mass here, they can add mass, which is growth over a very slow period of time, but they can also shed it. And maybe even in light winds, you'll see the little twigs coming off. This tree is balancing itself in its own unique wind environment constantly by growing one way and shedding over here. And it's not fixed for all time. It's a constant environmental adjustment. So it sheds as well as grows. So there are two mechanisms to balance. Of course, the growing is slow and the shedding is quick. So in a windstorm, if a branch breaks, it might be a shedding strategy. So it's not thinking, but it just balances itself, and it's overloaded in that sheds off, and then it retunes itself and grows accordingly. And I was talking to a couple of people from overseas and who have recently come to Australia, and a lot of us have been through the 2000 to 2012 millennium drought, 12 years of really, really severe drought. And Australian trees have adapted and grown to the Australian environment and have to survive long periods of low water. And I think they don't grow massively like giant sequoias, but they grow with this internal growth stress. There's like pre-stressed concrete. And in droughts, they shed limbs as a survival strategy. So it's not a shedding strategy, it's a survival strategy, because some species shed more than others. So it's a constant battle of survival in nature and adaptation, which is still going on.
I think that's all we've got. Thanks. But we've got time for general questions from the floor. Anybody, anyone about anything? Anyone about anything? Mr. Chisholm, you've only got 4 questions left for the day, okay?
Sorry, man. Sorry, everybody. Do you share Lockie's slight scepticism about the whole tomography scene?
100%. I definitely do.
Yeah.
I think it's another tool in your box, and you shouldn't trust it implicitly. What Lockie said about resistance drilling, we don't have a resistograph. Might be something we consider in the future. But in the absence of having one, I guess, it's probably relied on experience and good tree knowledge to make my decision more than being, absolutely swayed by a tomogram.
The mallet gets a fair workout, which I think it should. But I guess if you're putting a report together for a client, the mallet's a pretty hard thing to visualise for a client. And for your average punter, that may not be enough as well. again, as I said out on site, one of the big things for me is I do think it's a valuable tool. I do think quite often it's overused and unnecessarily used. And it should only be there to provide additional information. Like the software's interpreting the data, you've got to interpret the data, and then you've got to make the decision. It's not telling you what to do. So, yeah, there's a fair few steps there, without a doubt. So, yeah, it's not all smoke and mirrors, but yeah, treat it with a bit of caution as well.
Lockie spelled out a fair few of the pitfalls, and at the end of the day, it is a computer. It's a computer model drawing an image based on the data that it's got, which is the speed of sound, the speed of the sound wave.
Anyone, any topic?
So following on from earlier discussions, and I don't know if Ken or the rest of the panel might be able to give their point of view, but based off Mathic's T/R ratio being debunked over the last 20 to 30 years, where are we heading and who's providing the evidence of, I guess, some basis for us to work on in consultation on decayed trees in future?
So the whole T/R ratio, it has been debunked for not forever and a day, but for a long time. But as far as I'm aware, it's pretty much Ken's research that's the only leading light in the industry at this stage. So, yeah, we need more of it is the long and short of it. But again, it's got to get out there as well. So, yeah, if we're still using it, we really should be having a long, hard look at ourselves, I think. So,
Ken,
yeah.
did you get that question? With Mathic's TR ratio being debunked about 15 years ago, where's the new data set coming through that we can start relying on to inform ourselves about tree failure, whole tree failure?
I think the takeaway message today is there isn't much research going on. Money's dried up. Since COVID, things have...
Come up the front. And
up the front.
Lockie, Steve,
Yeah, since COVID, people are now working from home. Institutions have downsized. In Melbourne, 80% vacancy rate in office buildings. People don't work the same as they used to. Companies aren't paying for office space. They've restricted, downsized. Universities have downsized. The way we do things is different. So there's no money around except in forestry, because that's a commercial product that they have millions of dollars. There's a little bit of forestry. Some of the best forestry research is coming out of France, a place called CIRAD, Centre International Recherche or something. And if you know the history of France, Napoleon set up a system of growing wood for military purposes, ships, because all the Greeks and Romans cut most of the forests down for their ships. And he employed forestiers. And a forestier was a person who'd have a hut and he had to look after the forest, but he could use the firewood and the hunting and that sort of thing. And that still exists. So forestry is very strong in France. And over French oak for wine, for example, they're 400-year-old forests on a sort of rotation, and in windy areas they grow small, medium and large, and the wind, they sort of sculpture the landscape. So forestry is very advanced in some countries, and France is one of the leading areas, doing a lot of work on growth stress and internal stresses, which I worked on. But in Australia, nothing's much coming out in the literature. I showed you one or two papers. I'm keeping my eyes on the papers. Where do you find scientific research? I think everybody knows how to do a Google search. I did one on my phone just before I said this, make sure it works. If you type in Google Scholar and go to Google Scholar, you can type in the authors' names. And I would recommend, I did this whilst I was out there, and I'm not an expert on eucalypts, and it's interesting to hear people talk. But if you go back and do a search on Google Scholar and type in the name Jacobs, Jacobs, in about 1930s, Jacobs trees, it came up. it's a fascinating story of close observation of eucalypts, and it's amazing work that's sort of been lost. And I searched the libraries in Melbourne University, and we only had one copy of one of his papers. It's very hard to find. So there's a lot of information there that sort of gets cycled through, and this information from the old days is being lost. And we're now sort of entering a new era of trying to sort of verify things with research and put numbers on it. So I think one of the messages today is it all starts with a simple idea. And if you can have confidence in the idea and move it forward, I think we're going to get somewhere. And with AI, I think it's going to happen very quickly. For example, with tilt sensors, I'm looking for some electrical nerd, probably a late teens, early 20s, who's out there fiddling with all this and knows all about it. Has anyone heard of Raspberry Pi? That was coming out from England. It's a little microchip and allowing young kids to interact and talk with computers. Arduino, they're a little microchip data loggers, very cheap to set up and doing all that we're doing here for very low cost, but I can't use it. You've got to learn a new language of talking. But it's around, but it's not institutionalised, the research at the moment. But it's being developed in spite of us. It's in your phone, it's in your pocket.
I reckon, back to the TR ratio question, I think we need to move away from those absolute values of saying, hey, 1/3 remaining is okay, and start presuming that sound trees are fine. Everyone's thinks that, hey, an okay tree that's in the limits of stability, that's fine. We like that tree and we accept its risks, even though things can sometimes happen, and start comparing a tree against that and only doing things where they're not as safe as an already safe tree. And I do a little bit of that work, and you find that most trees are perfectly as safe for various reasons as that tree when you compare them. And there's some good work. If you look up these kind of size-based principles are grouped in a term called allometrics, and some good research by a fellow called Luke Fay in the UK. He's been presenting around. He has a famous father in trees too. He's doing a lot of work in these kind of establishing these size-based principles of assessing trees, and I think that's somewhere we can go. Instead, looking at things like taper, which really defines stability, and judging that across a tree instead of these arbitrary TR ratios.
So I just had a quick one in relation to the role of defects in trees in high wind events. Because I recently read, I think it was 2022 study where they looked at 1,400 trees that either had codominant leaders, included bark or extended branches, and then a hurricane come through and they went back and looked at all those trees again, and only 14 of those had failed, and none of those had branch failure at the point of those defects. Where amongst people that I'm often talking to, though, people are, I'm often hearing, if you see those defects, regardless of high wind events, they're, it's a hazard. Oh, the question was just how much weight is given to defects when.
Okay, with something like that, I would ask the author's name.
Yep.
What country? UK? Sounds like.
It was in North America.
North America.
Yeah.
I have some references, which I haven't got to today. Durea, D-U-R-E-A, I think, from Florida on hurricane winds. They've done a lot of studies on that. And basically they found it didn't matter the species of the tree, but they found in urban areas, it's really so basic, a single tree, and that's what we're talking about, what's the wind load on that tree, is more vulnerable than trees in groups. Trees in groups will survive winds better than trees separate. So it's not a species thing. And that makes a lot of sense because from my measurements, it's not just the tree, it's its environment as well, it's its wind environment. Particularly in cities, we find that a big mature tree that's been growing for many years and then a building's built close to it. within 20, 50 metres, the wind environment down the street changes. So that tree is suddenly loaded differently with that sort of wind whipping down the street and going around a building. So they're big factors. And it's modelled, but no one can really predict failure. And I've been giving this sort of talk for 20 years. And I can remember when I started out, I was very scared. I was thinking, question time. What if somebody asks me how to predict failure? I'm thinking, what can I answer? So before you ask me, I've been around the world asking somebody to put their hand up if they can predict if a tree will fail. You're all working with trees. And it's interesting, no one can predict tree failure at the moment. So that's where we're at. And no one's prepared to stick their hand up, because as soon as they did, I'd ask them, where is it? I'll go and put my instruments on it, because that's what I was looking for. I couldn't find it. I figured, when I finished university, I worked for a tree company, and we'd give seminars in Sydney, Queensland, regional areas. I figured with all the council workers and contacts, I had over 1 million trees to select from, and I was looking for someone to point to a tree that's going to fail to put my instruments on it. I couldn't find it. So it's just and it's a natural structure that's unpredictable at the moment. It's interesting to have the confidence to go away from somewhere like this, knowing nobody can predict when a tree will fail. Because it's not just you, it's because I've asked audience, well, let me ask, can anybody predict, did anybody know a tree that's going to fail? Now, sometimes there is, because you can measure the movement, we'll go and put our tilt sensors on it because we want the data. But I've been asking and asking for years. So before you ask me, I ask the audience. So I think I can confidently say no one can predict it. There's no method. We haven't got there yet. Maybe we won't. But we can do a lot of diagnostic work. And you actually touched on defects, and certainly they're important. So that's where the arborist's role comes in. You can confidently say you can't get an expert along to predict failure, but your experience and your knowledge of trees is a very valuable asset. And when you see defects, you get a feel for it. And we are still at that visual appraisal, so your skills are highly valued.
Can I add to that? So, how much do the defects, attribute to it? And I think, can you predict a tree that's going to fail? And I know that the answer for me is on the very rare occasion where it's happening right now. And the reason that I can't predict one now is because I stood there and waited for the crew to turn up to cut it down because it was twisting and moving and going to fall over the road. So I stood there directing traffic until it was cut down. So when we're that certain of it, we just generally don't have the time to go putting sensors on it. You don't have the time for that. So we're trying to predict an event in the future of something that is a living organism. It's going to be difficult. Back to the hurricane thing, after Cyclone Marcus in Darwin, there was a bit of anecdotal surveying that went on afterwards. A heap of the Chaya senegalensis, the African mahoganies, failed through Cyclone Marcus. So they went around counting how many of these African mahoganies had failed and done damage to houses, to dwellings, those sorts of things. But at the same time, they were also recording how many were still standing. And they found it was pretty much a 50-50 split between the number of these African mahoganies that had failed and hit dwellings versus the number that was still standing but had actually protected dwellings. So they'd captured fridges and cars and God knows what else and protected the dwelling. So for everyone where there's, I guess, one statistic, there seems to be something else that'll go the other way as well. So, yeah.
Do you have any long-term data, Ken, that you've had sensors on for a longer period? I know, Ben, that was out there for 2 weeks or a month.
2 weeks prior and then 2 weeks after. There, let's say 4 weeks.
Right.
3 weeks, maybe. 3-4 weeks.
Yep. But have you got any other sites that you've had it on for longer?
I do have long-term data. When I finished up with working for 8 years with a tree company, putting sensors around trees, and we had a major project in Brisbane, I counted up all my files and data sets. I had 750 million data sets. I couldn't even count, I got a computer to count them up. But by far the majority of my data sets are zeros. So if you're monitoring a tree at 20 times a second and there's no wind, you get zeros. So my suggestion to these companies was monitor 20 times a second, and in your software, record the fact that zero and just have a tiny little space in your memory, say 0. So you've got verification that nothing happened in that half an hour, but they're not doing that. They're recording it and they're fine. So there's lots of nothing data. But it made me realise that trees grow in that quiet period. The wind is a rare event. We see it as a sudden event. So I think trees adapt to the non-wind environment conditions a lot, as well as the wind environment. And winds of violence, looking at where we're failing. And I went to an earthquake conference in Western Australia once, and the president said, I think we've been making a mistake with his earthquake engineering, because they show a building of all the earthquakes and all the buildings that have fallen over. And he showed some of the slides, and what nobody's looking at, the buildings that didn't fail in the earthquake. And I've actually gave a presentation on earthquakes in San Francisco, and it's surprising. If you have a look at San Francisco after the 1906 earthquake, what buildings didn't fall over? What buildings were left standing after the 1906 San Francisco earthquake? There's some famous buildings. Go and have a look it up. Which ones didn't fail? No, not the wooden. All the tall, giant buildings. Because the frequency of the earthquake shaking did not go into the buildings. The energy didn't transfer into them. The giant tree, like the giant building, its inertia stopped the earthquake frequencies going in. So if you're ever in an earthquake zone, stay in a tall building, because the frequencies don't match the frequencies going in. So there's a lot of understanding of how the tree evolves and handles its environment, which we just don't understand at the moment.
Okay, thank you, Ken. And thank you, everyone.